All right, how's everything going? Cool. Any questions about anything? PA4 questions? Midterm questions? Yeah.
I noticed there wasn't any regex on the study guide. Is there not going to be any?
No regex on the midterm.
Okay.
I meant to put it on there and I forgot, so you get a break. No regular expressions on the midterm.
Could you kind of explain again, like redirecting input and what the pipe symbol
Sure.
was?
So normally when you run a command, if it reads from standard in, like with an fgets or a getcar, it's reading from your keyboard basically.
Right.
And when you send a standard out with a printf or an echo statement, it's sending it to your display. Okay, so if you have a command, it could be a C program, could be a shell script. If you say command and you say greater than and put in the name of a file, anything that would normally be displayed on your screen goes into that file instead, right? And if you say command less than file, anything that it would normally read from your keyboard, it reads from this file instead.
Oh, okay, that's kind of what was throwing me.
Okay. My screen's totally off. Well, I just wrote command greater file, command less than file, so that'll take 20 seconds to warm up, but I'll show you an example. All right, so here's a script. It says enter something, it waits for you to type in some words, and then it shows you what you typed. Right, so 3-line script. So enter something, hello there, it says you typed hello there. Okay, here's a file called text. It contains 1 line of text. So if I run scr and I say less than text, it says enter something, you typed A, B, C, D, E, F, G, H, I. So it read standard in from that file instead of from the keyboard.
Okay, that makes sense.
Okay, here's another script, scr2. It just does a couple of echo statements. And if I run scr2, it shows me my output here. If I say scr2 greater than, I don't know, ff, I don't see anything on my display when I run it, but now I've got a file called ff that contains the output of that command. And then the pipe basically, right, so remember scr, you type something in and it shows you what you typed. So, for example, pwd shows me what my current directory is. If I say pwd and I pipe that into scr, pwd, instead of showing me my output on my display, will send that output into the input of scr. So now scr says enter something you typed, and there's the result of my pwd command.
Okay, that makes sense.
Okay.
What I was reading was way more confusing than that.
Most likely, yeah.
It's a lot more stuff I can do.
Yes.
Yeah. It's,
But yeah, that's the basic setup. So doing command 1, pipe into command 2 is kind of like doing command 1, putting the output into some file, and then doing command 2 and reading from that file. But it does this without having a temporary file. So it's just connecting inputs and outputs together. All right, so we're gonna talk about some kind of randomish. Show what? This one. So we're going to pick up some kind of loosely connected topics in Bash. And we'll take this into next week also. So tomorrow's your midterm, obviously. Monday there's no school. So Tuesday we'll probably spend talking about the midterm. And then Wednesday we'll finish up what we're talking about today, which is just a series of topics in Bash that aren't really critical to daily life, but things I want to go over. Sorry? Say again?
Monday, Monday.
There's no school Monday.
Right, and then
Tuesday we'll talk about the midterm, because the midterm's tomorrow. So we can do for loops in Bash. And the general format is for a variable in, and then curly bracket, start dot dot end. So for I in curly bracket 0 dot dot 10, do echo I equals $I, done. And so there's a simple for loop. So no big surprises, basically the same as what you would do in C. The default increment is 1. And it just sets I to the initial value 0, checks to see if it's less than or equal to the second value, and if it is, it executes the body of the loop and goes on. And if your second argument is smaller than your first, it does the right thing. It changes the increment to -1. So it's smart about that. And you can also specify an increment other than 1 by putting in a third dot dot 2. So this will say I goes from 0 to 10 by 2s, and so it does my even numbers. No big surprises there. And you can do this with a while loop, right? But it's just a little easier sometimes, having a for statement. Okay, there's a different way to do iteration, and this is pretty popular in Bash. It also pops up in other languages, Java, Perl, etc. And the idea is sometimes you have a list of words, say separated by spaces, and what you'd like to do is some body of a loop where you have a variable equal to word 1 and then equal to word 2 and then word 3 and then word 4, and you'd like to iterate across all of these words, right? So instead of having a variable be equal to 0, 1, 2, 3, 4, you want your variable equal to this word, that word, that word, that word, right? So there's a syntax for that. So for variable in, and then you list the set of values that you want that variable to take separated by spaces, and then do and done. So for example, for x in, this is a test, do echo x equals $x, done. So what this is going to do is it's going to say, okay, I'm going to set x equal to each of these values one at a time. It's going to set x equal to this, and then it's going to perform the body of the loop. And it should say x equals this. It's going to set x equal to is, perform the body of the loop. X equals test, and there's nothing left in this list, so that'll be the end of the loop. So it's a way to iterate over words instead of just integers. So here's some sample code. I'm going to set I equal to 1. That's just going to count how many words I've processed. I'm going to ask the user to enter some names. I'm going to read what they type in, store it in the variable names, and I'm going to iterate over the words in that variable. So for n in names, and inside my loop, I'm just going to say name, whatever the value of I is, equals, and I'll show the value of n. And then I'll increment I at the bottom of the loop. So enter names. Don't know any names. Make sense? So one place where this is especially handy is processing command line arguments. So $* right, $1 is the first argument, $2 is the second argument. $* is a space-separated list of all the command line arguments when we run a script. So if we just echo what $* equals, and then I'll just exit right there. Right, if I say this is a test goodbye, $* is equal to this is a test goodbye. But what that means is that I can iterate over those arguments using this for variable in notion. So for arg in $*, right? And so arg will take on the value of each of the command line arguments one at a time, and for each of those argument values, it will execute the body of this loop, which will just show me argument I equals whatever the argument is. So if I run for2, this is a test goodbye, I can pick up my arguments one at a time. So I should give you a heads up. Part of why we're doing this extra bash stuff is because your final programming assignment, PA5, is going to be a bash script. It's going to be a group project, and it's going to involve making a GUI. And I'm going to leave most of the design details completely up to yourselves. So you get to make it as fancy or as straightforward as you want. And so things like this can be useful if you're picking up command line arguments and you want to process them one at a time, right? This lets you iterate through them and do whatever you want with each argument. So these things we're talking about might be useful for PA5. So we have until statements available also. And an until is basically like a while, except that we exit the loop when that condition is true. With a while statement, we run the loop while the condition is true. We exit when the condition is false. But other than that, they're basically the same. So until I is equal to 5, do show me the value of I and increment it. So it works from 0 through 4. The last increment sets I to 5. The until condition is satisfied, so it exits the loop. So that can be useful sometimes. Okay, so we can do case statements in Bash. They look basically like switch statements in C. It's nothing you can't do with a bunch of if-then-else's, but sometimes it's cleaner to have this structured as a case statement. So suppose, let's make this something better. So we'll let the user say start, stop, or quit. Okay, so we're going to say case, $word in. And now we're going to list all the possible cases. So one possible value for word will be start. So we'll say start, right parentheses, and now we can list whatever statements we want executed if word was equal to start. So echo and do whatever you want to do. And then when you're done with that case, put in 2 semicolons. Okay, and then we can have the next case, which is if they say stop. And then if they say quit, and we'll throw an exit in there. And then you can have a default case, which you do with an asterisk. Oh, I need my semicolons. And then at the end of the case, you do ESAC, case spelled backwards, just like fee versus if. And let's throw all of this in a while loop. So, barring typos and silly mistakes, this should do what we expect. So choose start, stop, or quit. So if I say stop, it says shutting down process. If I say start, it says starting process at, and it shows me the date. If I say ha ha ha, it doesn't know what I'm talking about. And if I say quit, it says goodbye and it exits the program. So it's a convenience. Yes?
Do bash cases have the same tendency as C, where they will cascade down if you don't stop them?
Does not appear to. Because when you say start, it says starting the process, it shows the date, and then it does not go on to.
Is there a way to have it do that, or is that just not?
I don't know what happens if we leave off the semicolons. Let's see what that does. Nope. Yeah, I don't think there's a way to do that, although there's probably some way to do it. But I don't know what it would be. So yeah, it's like there's an automatic break. All right, so you have switch statements available, cases. So bash will do regular expressions, and we can do it as follows. If bracket $word, bless you, and the syntax is equals followed by a tilde. Okay, and equals follows by a tilde says I'm going to specify a regular expression on the right, and I want to know if the thing on the left matches that regular expression. So if $word equals tilde, let's say caret Z. Then we'll print out a message saying your word starts with a Z. So caret Z, remember, is a regular expression. Caret is an anchor which says we have to start at the beginning of the input, and the beginning of the input must be followed by a Z. So basically we need the first character of the input to be an uppercase Z. And so this if statement says if the value of word matches that regular expression. So this if statement will be true precisely when we type in a word that starts with a Z. So let's run this. So I can type hello, it doesn't do anything. I can type haha, it doesn't do anything. If I type zebra, it tells me zebra starts with a Z. All right, so if I match the regular expression $, it tells me that I need a word that ends with an X. So, haha, hex. Hex ends with an X. If I say it has to match X period $, what's that going to match? Yeah, X followed by any character followed by the end of the line. So anything where the second to the last letter is an X. So hex does not match. Hexes does match. Hex X matches. Right, so these are just regular expressions, the kind we talked about before. Right, so if I match the pattern caret ... that'll match anything that has exactly 3 characters in it. So hello doesn't work, cool doesn't work, ABC does, 1, 2, 3 does, A space B does, A space B space C does not. So this is another way to experiment with regular expressions. So what is this regular expression going to match? The expression is just the letter X. So what kinds of words will match that? X will match it. Anything else? It's so simple that it's really confusing. Anything with an X, right? And we usually have anchors and things like that, but this is a valid regular expression, and it says somewhere inside word that there has to be the letter X, and it can be anywhere in the word. So that's actually just saying your word contains an X. And it could be at the beginning, it could be at the end, it could be a bunch of X's, makes no difference. So if you like regular expressions, if you're becoming fluent in them, right, you can throw them into your scripts and do all kinds of awesome processing with them. And without regular expressions, trying to do this is a nightmare, right? Trying to figure out even if your input has at least 5 characters in it, right? It's tricky to do. If we want to know if it has at least 5 characters, we just have to say, does it match the pattern? Dot, 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 dot. Make sense? All right, so we got regexes. Yeah.
Would that be one of the ways to speed up the sorting algorithms?
Oh, sorting with regular expressions, that would be interesting.
Because you could just have it look for other expressions that have been used previously in your other phrases.
Yeah, possibly. Although Wednesday we're going to talk about a way to do PA4 in Bash. That's about 10 lines of code.
Okay.
Yeah, Bash is good for some things. All right, let me talk a little about processes. So we know the PS command, it gives us information about processes. So when I say PS, there's 2 processes here. There's one called Bash, that's my shell, 21078, and then there's a process called PS, that's the PS command I just executed, and its ID was 22607. And if I do PS-L, my PS command has a different process ID now, 22609. My Bash shell is still 21078. This second column, S, that stands for state. And a state of R means the command is running. A state of S means the command is sleeping. So when I executed the PS command was running. Well, that's not surprising, because that's why it was printing out the output from PS, because PS was running. And the Bash command was asleep, right? It was basically waiting for PS to finish. All right, so I can come over here and I can do a PS, and I've got a Bash and a PS, and they have different process IDs. This Bash shell 22564 is totally separate from this Bash shell 21078. Now, when you have processes, it's generally pretty hard to share information between them. You could drop stuff into a file, and any process can read the file if it has permission, so you could pass information back and forth like that. But how would you tell one process, hey, I put something in a file, I'd like you to go read it and do something? So it's useful to have a way to signal processes, to send a ping to a process to get its attention and get it to do something. And we can do this in C, and we'll learn all about this in C towards the end of the course. We'll learn about making processes and communicating between processes, but we can also do it in Bash. And so there's a general command called kill. It's a violent sounding command, but it doesn't actually kill a process, it sends a signal to a process. But the most common signal we send to processes is basically the kill signal. So the command is called kill. But for example, I can say kill, and I'm going to send a signal called sigint, sig interrupt, and I'm going to send that to my Bash shell over here on the left, which is process ID 21078. And my window on the left there displayed a Control C. Right, Control C, which is also what you get when you hit Control C. So sigint is basically a Control C. And so over here I might be doing something like just some program that's just printing out haha over and over again. And from over here I can send a sigint, and it interrupts that process. Or I could be sleeping for 100 seconds, and if I send a sigint, but it's not the Bash shell that's sleeping. right? That sleep process is actually process ID 22632. So I can send that a SIGINT. All right, so you can interrupt processes. You can send a signal 9, it's called SIGKILL, and it'll terminate a process regardless. And if you say trap-L, you get a list of all these weird sounding signals that you can send. SIGHUP, which is a hang up for like hanging up a phone, SIGQUIT, SIGTRAP, SIGKILL, and so on and so forth. But in Bash, you can arrange that if I get a signal of a certain type, I want to do something other than the default action. For example, SIGINT generates a Control-C. It interrupts my current process. But I can do something over here. I can say, let's trap a SIGINT. And when I get a SIGINT, I want to say echo, ha, ha, ha. So this statement says if someone sends me a SIGINT signal, instead of generating a Control-C, just echo, ha ha ha. And now over here, if I kill that process with a SIGINT, it says ha ha ha. So kill lets us send signals to processes. Trap lets us define what a process should do if somebody sends it a signal. And so that's one way we can communicate between processes. Probably won't need to do that for PA5, but you could get really fancy and do that. But it's a generally useful capability. And not every signal is trappable. So I can try to trap SIGKILL, but SIGKILL is untrappable. So it actually turned my text red, and it told me that Bash crashed. And this is very much gone now. So like I say, we'll do this from C. We'll look at creating processes and sending messages to processes and communicating between processes. And this is related to another topic I want to touch on, which we've talked about to varying degrees. So if you have a program running and you want to kill it, right, Control-C is the way to kill it. Now, if you use Control-Z, it gets you back control, right, so you can type things and be back at your shell. But if you keep doing this, right, all of those commands are still sitting out there. And if you do this on the server, like your assess program isn't doing what you want and you hit Control-Z, that process still exists. It's not running right now, but it's still taking up resources. And eventually you run out of resources, right? So if you log out, those will go away. But I can also look at these jobs by saying jobs, and it tells me I've got 5 jobs and they're all stopped. And if I do a ps-l, the state of those jobs is T, which is the code for saying the job is stopped. Now if I say foreground and I put in either the process ID or a % followed by the number in brackets, it brings that command back into the foreground, and now it's as if I had never hit Control-Z. So this command is running, and if I hit Control-C, it will kill it. And now if I look at jobs, I've only got 4 jobs, and there's my 4 sleeps. You can also tell a job to start running in the background. So I can say, for example, background %3, and now if I say jobs, job 3 is running. It's in the background in the sense that I still have control over the keyboard, right? Bash is still listening to me. But if I do a PS, that sleep command is in a state of S, which means that it's active, right? It's sleeping because when PS ran, PS was the only job running, but it's not stopped. So I can kill all of these. Kill %3, kill %2, %4, %5. Right, and now all those jobs are gone. You can kill yourself, but it's a soft kill. But if you kill yourself with a sig kill, you're gone. All right, so Bash also has a way that supports menus, and this will probably be useful in PA5. So we can do the following: select, I'll just call it C in, and I can list a space-separated list of options. So start, stop, continue, quit. So let's just do this. Select C in, and I'll say start, stop, continue, quit. Well, if I run that, oh, maybe it really wants me to do something. Okay, so let me cat the code out so you can see it. So select C in, start, stop, continue, quit. So it shows me a menu with those 4 words in it with a number in front of each of them, and now I can select one of these options by number. Right, so if you don't trust your user to be able to type correctly, say they want to continue, they type in a number 3, and my variable C is now equal to continue. Right, so it's as if they had typed in the word continue, but they can make their selection with a number. And if they put in a number that's outside the range, then your variable is just empty. So we can use this to do various things. So we'll have them type in an option, and if the option they typed in is equal to quit, then we'll go ahead and we'll say goodbye, and we'll execute a break statement, and break takes you out of your current loop, and we'll confirm that happened by using an echo statement outside of the loop. So I can say start, continue, stop, continue, and then if they use option 4, it says goodbye, and then we're outside the loop. And again, you can do this with a bunch of echoes and a bunch of reads and a bunch of if-then else's, right? But this is just a whole lot simpler. And Bash scripts, usually, you're writing scripts because you kind of want something quick and dirty, right? Not necessarily as solid as a C program, but something that you can develop in a few minutes instead of maybe a few hours. And so things like this sort of lead to a much more rapid development. All right, so let's tackle another mystery. So here's a variable x. I've set it equal to hello. So here's a one-line script called show that will show me the value of variable x. So x is equal to hello. if I say show, it tells me x is equal to blank. And I can set x equal to 12, and x is still equal to blank. And inside this script, we don't seem to have access to this variable x. And this is similar to the following. So from here, I can say bash, which starts a new bash shell, right? So my prompt went back to 1999. And if I echo $x, it doesn't have a value. So these assignments of variables are basically local. And they're local to this particular bash process. So if I print a PS in the beginning of my show script, you can see that show is its own process. It's got process ID 22741, right? And it ran a PS command, which was another process. So it's this process, 22741, that's trying to show me the value of x. And that's a separate process from the process where I gave x a value, right? So every process basically has its own context. So there's a way around that, which is just to say export and the name of your variable. And when you say export, it sets things up so that whenever you create a new process, the value of that variable will be passed to the new process. So now if I say show, it'll tell me x equals hello. And if I say bash and I echo $x, it'll say x equals hello. And if I say bash again, the export will carry over, and x will still equal hello. Now I got 3 bash processes. So export kind of makes a variable global in bash. It's not exactly like a global local, but the effect's kind of the same. So in my bash RC, remember bash RC gets executed every time you log in. I set up my prompt PS1 to be equal to your command line number inside brackets. And let's say I want to get something different. I want to set my prompt to be equal to hello. So I go ahead and I execute my bash RC. And my prompt doesn't change. And it's because when I execute bash RC, it's running in a different script. So for example, I forget what I called it, show. Right, inside here I'm going to set x equal to goodbye. So x is equal to hello, I run my show, I echo x, and it's still equal to hello, right? Why? Because when I said show, that was running in a separate process. And in that separate process, x got set equal to goodbye. But when that process exited, I came back to bash, and this version of x was never touched. So instead of just saying show, which creates a new process, there's another command you can use. You can say source and type in the name of a file. And this does not create a new process. It basically reads each line from that file and executes it in your current shell. So if I say source show, and then I echo $x, right, that's got the new value. So source file name is basically like typing each line from that file in your current shell. So if I say source ~/.bash rc, that changes my prompt. All right, let me show you something else we can do. So, in a script, we can say the following. We can say command less than something. And then we can list a bunch of lines of text, and then we can have a line that by itself just says whatever this something is. And what this does is it executes command, but it reads standard in from all of this stuff. So it's not actually reading from a file, like we said, command less than file name. It's saying I want to read standard in from all the lines that come after this until I get to a line that just matches whatever something is. And usually people just say like EOF or EOI or something, but it's not a magic keyword. It can be anything, and as long as that's the same thing, it'll read from there. So let's see if we can do a quick example. Okay, so what am I going to do? I'm going to say, here we go, and then I'm going to say, execute the cat command, and instead of reading from standard in, read from these following 4 lines, right? And I know I wanted to read from those 4 lines because I said read until you get to a line that says end of input, which is what that 5th line is, and then I'm going to say goodbye. And cat normally reads from standard in, copies to standard out, which is normally a silly thing to do, but in this case it's going to read from these lines, and then it's going to send those to standard out, which means I'll see it. So this is a way to display a bunch of information from inside the script without having to say echo, 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 echo. So if I run this, oh, I messed up.
Maybe we could buy.
Alright, so here we go, and then it basically echoed all the lines that I had in the middle, and then it said goodbye. So if you want to, I'll put 100 lines of text in the middle of your script. You don't need 100 echo statements. You can do it with something like cat. Or if you have a program that you want to run and you want to feed input to it, you don't have to create a file that has all that input in it. You can actually put the input in the script itself. And that's sometimes useful. All right, so we'll leave it there. So don't miss your exam.